First of all, I want to thank you to the IAS for it's an honor to be present here and be also a keynote speaker. That means we can, let me say, present. We prepared a small presentation regarding me, myself, and especially our teams. This is a pictures of the very close inauguration of the Expo 2020 in Dubai. That the construction is done by us, is Al Waz Plaza. But here a small history about Maffeis Engineering. As you mentioned, I started alone in 2000s after my degree, and is maybe funny to show to you a circus tent that is one of the most historical fabric structure or canvas structures. I started in this business not because I was looking for that, but it was the occasion. I born in a small town, let me say, in Bassano, there was two companies that was building a circus tent all around the world. And I started to develop, working with one of them, I started to develop a software for form finding and cutting patterns of circus. After a few years, we was doing more than 100 circus a year. And since that times, now Maffeis Engineering is growth. We have a team of 180 people based here in Italy. We have 25 staff abroad. We have 13 office worldwide, starting from Australia till US, Canada, and New York. I mean, we grow a lot. But more than that, I'm very proud of the team that I was able to build, and especially, let me say, on the job that we was able to achieve. As it was mentioned by Mary, we are now very much involved. Our core business is about special structure and fabric structure, cables and stadia. But we enlarge our presence in facade, bridge, movable structures, and special structures. We are remaining very close to the developing of the software. In Maffeis Engineering, we are pushing a lot on developing new softwares for our own use, for form finding, analysis, and FEM, especially for fabric and cable and C structure. We are using parametric software that is integrated with our systems of work that we call in our project OSM, one single models. I mean, everything is going in a central unit that we call is the core of the software that we are using day by day in the office, all our people. And this one single models it became for us the leading path of the day-by-day jobs. Here you can see now we will go through some of the jobs that we developed and we was able to build in the past, let me say, years. Of course, we start for the Qatar World Cup 2022. This is Al Janoub Stadiums. In the beginning, it was called Al Wakra. It was original jobs done by Zaadid. Later on, we entered in the project as a value engineering proposal. And in this project, we developed the entire structural calculation, starting from the foundation till the roof and the cladding. Involved, as I was mentioned to you, as a value engineering. I mean, value engineering means that there was a project and it was looking together with the construction company for a cost optimization solution. Here is, you can see, let me say, on the right side in red, what was the original one. On the blue, on the left side, you can see the optimized section. Of course, we was in the team with architect, with the MEP, together, so let me say, to develop this alternative solution that has been built, is already inaugurated and ready to be used. Here is some grasshopper application. That means it was easy, let me say, exactly working with a parametric approach on the project to see how to optimize the work and the reduction on the steel, on the concrete solution, and in a faster way, let me say, be already on the BIM software and also on the FEM analysis software. Also integrating on our code all the application or all the numbers coming from the wind tunnel test or the CFD. Preliminary CFD was done by us internally. We have a team that is doing such kind of application, and it was later on confirmed by the wind tunnel test later on done. You can see also for the cladding, it was studied, let me say, with an optimization tools developed by us. Is a trigonometric structure, but we try to some tools try to optimize to get only planar systems that we can go and get cold bending. That means all the systems it was built based on the planar panel and not 3D carved panel. All the job was managed, let me say, in pre-COVID, but in any case, we was a company in Italy, the architect in France, the MEP in Belgium, and all the coordination was done through a BIM platform, and it was done in very quick times. It was a really fast-track job. That allow, let me say, these systems to speed up the jobs, let me say. This is Khalifa Stadiums, is a refurbishment of an existing stadiums. It was covered only one side of the stadiums. That means we work on the demolition of the lighting arch, the demolition of the existing roof, half moon we call. And it was built the second part covering left-hand side with a W compression tension ring systems. We was involved in this project as a designer in the beginning with the architect, and later on we jump with the contractors to develop all the construction phase, erection sequence analysis, detailing, engineering, and construction engineering. That means it was, let me say, develop the entire detailing, not only the design, but the detailing engineering for the construction, all the erection sequence. You can see here some simulation of the compression ring. As it was the same thing was done for the demolition of the existing part of the stadiums, and was done by us all the erection sequence for the cable, and that means we follow up also on site during we was on site supporting and checking during the erection, the matching with the numerical model with the site. That is really important to matching the two things. And we was working in all the details, detailing for the clampings, detailing of the scaffoldings with the cable company, with the erection companies. I mean, we got really site experience, and from experience, speaking by experience, let me say, only design without the site experience, sometimes you can be as good as you wish, let me say, on the design, but without the site experience and the problem that you can get during the construction, is not easy, let me say, to manage a job and manage also a good design. And this is also the strengths that we have in Maffeis Engineering. A lot of our job is related to construction, also erection sequence. That means we have really the experience of the site that is helping us a lot when is the time to do a good design, let me say, because you start from day one in designing something that is buildable. Here we was involved also on all the temporary phase. That means it was studied by us also the temporary phase related to the fabric. But in these jobs, we got involved from the A to Z, let me say, also on the cutting pattern of the fabric. And all monitored and governed by parametric models, what we call one single models. That means from the steel structure modeling, cable erection analysis, and this is done with our tools and with our software. This is another jobs, is a Museum of the Future in Dubai, where as a Maffeis we was involved for the detailing design of the connection and all the erection sequence. That means we take care of also for the cladding, this part in these jobs. That means we take care of the different part of the building and the different construction phase of the building. Taking care of precamber, defining the precamber systems, preset, and locking force generating during the construction. Sometimes the locking force is really important, the design of the construction, because the locking force can be, let me say, really a designing point for some of the element that is part of the scope. You can see here where we start, let me say, from the basement, that is nothing to do with us. But you can see the models of the construction, and it was, I think, 550 or 560 stage construction considered, only for the stage. Later on, we got all the node that is all different each others. That means the temporary scaffolding, supporting, and also when we was out of tolerance, let me say, how to manage, let me say, to bring the structure, doing the rectification that was needed to get the structures on the correct geometry. Yes, here is some of the pictures of the construction stage and the analysis about the locking force done from the base FEM analysis till the construction site. Many times we have to realign, let me say, what is the construction stage with the constraint of the site that sometimes we cannot follow. That means we have to be present and ready on site, trying to manage any modification that is needed to bring back the structures to the original plans. Here you can see, let me say, some of the stage construction with all the coordination on the node and the. But we take care also of all the mechanism, device that is needed to do this operation, cylinders, strain jacking systems. That means we are involved with the contractors also on this work, let me say, and developing also special systems that can be used for the project by projects. Also, the nodes was studied, all developed by us. We changed from the original concept that was a crossing plate passing. We changed also to optimize time and construction with master pipe and the slave pipe systems. That means it was developed the entire FEM for each node. 498 node, if I'm not wrong in the numbers, all different each one, and all the nodes was developing in parametric way for the application of the load and also for generating the FEM in real time. So you can imagine what means 498 node to be built, modeled by hand, let me say. This is all coming from parametric models and bringing the FEM in automatic way, apply the load on the node in an automatic way, and of course checking the double check the weldings and also the resistance and the locking force. This is another job that we was involved from day one, from the tender stage, together with Chimolai and Vinci, is the new Roland Garros. And we was involved from all the steel structure, from the design point of view, and also from the retractable roof. Sorry. Here is some view of the stadiums. We have the beams of the retractable roof. That is, the height is 2.2 meters, but they are spanning for 118 meters. That means we got a lot of interaction about the possible interaction with the wind and the vibration of the beams. Preset of the beams, because you can imagine that 2.2 meters and 118 meter span is a very tiny beams, let me say, as the height. That means we got a really preset of the beams. If I'm not wrong, we was more than a meters. That means also the erection sequence, the construction, strand jacking on top, it was really complicated. And the vibration and the interaction with the wind was one of the key points on the design of this element. It was done also in CTB in France, also dynamic analysis on the models to see the vibration times. And it was verified with scale 1:1 in one beams if the vibration times it was matching with the estimation that was done by FEM. Here is some pictures of the construction. And also here we was involved for the full design, and also together with the steel contractors, Chimolai, developing also the construction sequence and looking at the connection and direction phases. Looking the detailing on the engineering, buckling and reinforce on the structures. This is one of the reference project. I think Expo 2020 will be open beginning of middle of October. This is the central domes of called Alwas Plaza. We was involved on all direction sequence, connection details, developing the installation regarding steel and also fabric. The method of installation here, we got a part that was built on scaffolding and one dome that later on a big dome, 118 meters, was strand jacked till the top. You can see the post where the strand jacking was fixed, let me say, all around. And of course, the key point was the matching, let me say, of the construction. Here you can see some sequence of the construction, and also, and this has been checked, let me say, on site. That means it was the reference point for the construction on site. Also from the preset and for the coordinate, and also the locking force of the element during the construction. This is all the phases that was followed up on site. And we have the central dome that it was built, let me say, on the ground, also with all the reference and the sequence, let me say, of the construction. And the strain jacking systems with all the sequence and the operation on site till the connection with the lateral site, till the structure was stable, let me say, with the closing of the domes. And we take care also of all the fabric and the installation of the fabric on top with the detailing engineering for this part of the jobs. Yes, here you can see also some detailing regarding the tools and the device, and that was developing positively for the projects. You can see some strain jack systems, the application, the anchoring on the ground and on the tops. I mean, part of the job that is part of the design is also this one. That sometimes is leading the design that have to be taken care from day one. Here to show to you, and you can see that the special, let me say, detailing for the connection, the thinking how to install, go to connect, and sometimes is more critical than not the real design of the entire structures. Here is some point of controls, let me say, in between the models and the construction phase. It was out, let me say, the maximum discrepancy in between the design and the construction was 6 millimeters on the nodes. I mean, I think is in a structure that is 148 meter wide, I think is a good tolerance on the design, construction, and direction point. Also, these jobs is fully developed from parametric approach. That means is using our tool that we call one single models. That means we have under controls design, the FEM, the geometry, and the models, let me say, the BIM models or the Tekla models on the real times. Here are some pictures from the construction site, from the warehouse, and also, let me say, during the installation. Okay, this is, I want to thank you again for your times, and especially for the nomination, but especially also for the invitation, let me say, to the IAS. It's really an honor to be here and be, let me say, present on these events.